A commercial resupply mission delivers to the space station, visits from recently returned space station astronauts, and using deflection as a technique for planetary defense. A few of the stories to tell you about this week at NASA. On May 6th, SpaceX's Dragon cargo spacecraft arrived at the International Space Station 2 days after being launched from Cape Canaveral Air Force Station in Florida. The Dragon delivered more than 5,500 pounds of research, supplies, and hardware to the orbital complex. It will remain at the station for approximately 1 month before returning to Earth with about 3,300 pounds of cargo and research. Our Drew Feustel, who served as Space Station Commander during Expedition 5556, made several post-flight appearances in the Washington, D.C. area, including a short presentation May 9th for employees at NASA headquarters. The week before, our Ricky Arnold, a member of that same expedition crew, also visited D.C. Arnold and Feustel returned to Earth October 4th after spending just over 6 months on the station. Our Double Asteroid Redirection Test, or DART, is the first ever mission to demonstrate a planetary defense technique that will deflect an asteroid by colliding a spacecraft into it at a high speed. The mission's target, Didymos B, is the small moonlet orbiting a larger body in the binary asteroid system Didymos. Performing the test with a binary system will enable researchers to more easily observe changes to the orbit of the smaller body than if it were a single asteroid orbiting the Sun. DART is targeted for launch in June 2021. It will intercept Didymos B in October 2022 when the asteroid is within about 11 million kilometers of Earth. For the first time, our Mars Odyssey spacecraft captured imagery of the Martian moon Phobos during a full moon phase. Each color in the new image represents a temperature range detected by the Thermal Emission Imaging System, or THEMIS, Odyssey's infrared heat vision camera. THEMIS has been studying the moon since September of 2017. This full moon view is better for studying material composition, whereas half moon views are better for looking at surface textures. A pair of interns at our Langley Research Center in Hampton, Virginia, are using 3D printers to develop a series of soft, flexible robotic actuators to investigate the viability of using soft robots for future space exploration and assembly tasks, possibly during missions to the Moon and Mars. Being constructed from highly flexible materials such as silicone enables soft robots to move more like living organisms, which allows for an increased range of motion that traditional metal robots do not have. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.